Well, hello everyone. I'm Matias Vara. I'm going to present how we are trying to improve the querying of VCPU statics in Zen, and particularly this shot regarding my current job in Vates. Sorry. I hope you enjoy the presentation and thank you for coming. Who am I? I'm passionate about operating system and virtualization. I used to work at Citrix, and then I moved to Tech, Huawei, and I'm currently working at Vates and Vates, where I'm trying to contribute to Zen and the ecosystem. I just joined Vates in last February. And the presentation I'm going to talk about today is about a discussion I have with Andrew in February. And since then, I have been working on this, and the presentation is the result of this. So I have to thank also Andrew Cooper to give me this idea. And so the first question that you can ask is, why do we need statics? And for example, here you have a screenshot of the Zen orchestra, and you have a graph, like for example, the CPU sesh. And in general, statics help you to understand how well I guess behave in terms of, for example, memory usage, CPU usage, or then throughput in the network or in the disk. And the question is how these counters are got, and this is what I'm going to talk next. So in xcp-rrdd, what we have is a tool called xcp-rrdd, which is a tool in DOM0 that is periodically collecting stats and stored them in a RRD format. So some of the counters or the information that this tool gets is, for example, the VCPU info and the run state info. The first one is for a sparse VCPU, and the second one is per domain. And this is, for example, information about a VCPU, how much time the VCPU is actually running as a physical CPU, and so on. And for example, in xcp-rrdd, what happened is that this tool is querying these values every 5 seconds per every VCPU in the system. So how actually this is implemented? Well, at the end, this ends up with a hypercall. And depending the counter, is going to use different hypercall. So we see which counter exists and which are the interface that they are using. We can list different counters and different interfaces. So how we have basically two interfaces, which are the cctl hypercall and the non-cctl hypercall. And so how is actually this implemented? Well, generally speaking, what happens is that you get the spinlock, either the DOM-CTL or the cctl spinlock, depending on the counter. Then you get the counter, you copy into the guest, and then you release the lock. For example, in particular in this slide, what we see that is that when we get counters from a particular VCPU, we are also relying on other locks, like the RC read lock. So in general, what happened is that the whole, during the threading of the hypercall, we hold the DOM-CTL spinlock in the whole hypercall, and this is the spinlock that is also shared with other operations, like for example, create domain or resume domain or destroy domain operations. So we observe two drawbacks on this. First, query counters require holding the DOM-CTL spinlock, and does impact other operations like create domain or destroy domain. And also, we also observe that the query requires different interface depending on the counter. So, what I'm trying to say is that the interface was not so homogeneous when we wanted to query counters, right? In particular, in the first case, what happened is that we are issuing a hypercall for each VCPU in the system every 5 seconds, for example. And we thought that maybe we can do it better. So, for example, trying to not use the hypercall. So we started to evaluate different solutions on this. So the first solution was to remove the spinlock dependency, for example. But then I was not really sure about what will be the impact of doing this, because I was not really sure why the spinlock was not there for this reason, right? For this counter. And second option was, for example, to use the VCPU of register unstable memory area, which allows to map in the guess a region of memory in which the hypervisor is going to write the counters that I was actually querying. So this avoid the use of a hypercall, right? And but this was not good for the use case that we have, because what we have was a tool in DOM0 querying it, but this is only for the guests to get their own registers. So it doesn't work for a tool in DOM0 to get it. For other domain, I mean. So the third option was to try to rely on acquired resource to expose VCPU domain counters, and this is what I'm going to present next. So first, the first question is, what is exactly acquired resource interface? So what is it's just it aims to share a resource from a specific domain that not belong to SEN with a domain with enough privilege, like for example, DOM0. Currently, there are 3 resources. There are the event table, the IO request service, and the VM trace path. Just to have an idea, a more concrete idea, what I'm talking about is, for example, a QEMU, which is a process in DOM0. It uses IORX server for a particular domain. I mean, if you want to know more about the acquired resource interface, I have been submitted a request for comments explicitly to document this interface. So if you want to see that patch, feel free to do it. So how exactly a resource is accessed? Well, a resource is represented with a page that is allocated from the DOM heap, and then the pointer to this page is most of the time keep it in a structure, like for example, struct domain. And then the tool in DOM0 is going to, for example, use the SEN4NA map resource to map this page on their own user space. So at the end, you get this data by using shared memory, usually speaking, let's say. And so instead of having a hypercall to query, you have just there, and you let the hypervisor write to that region. And so yeah, we have some sort of minimal requirement for the proof of concept that we wanted to do. So what we said is, let's just expose what is required for xcp-rrdd for the moment. Maybe there will be another counters in the future, but let's just focus on this. Then the second question was how to expose it. And I have several interesting discussions on the SEN level mailing list, because my first option was not really good. And so what we said is, well, we're going to allocate 1 page per domain, and then we keep per VCPU information there, and then doing in a way that we have in mind that this structure is going to be maybe extensible in the future. So we cannot limit that. And then another question was when we were going to allocate this information, because not everyone wants to get these counters. So maybe you want to do it for some guests and not for another one. So the allocation is going to be on demand, let's say. And the third question was when we're going to update these counters. And I decided to do it in the VCPU run state change, for example. So we have the second version of the proof of concept. We propose a new resource called stop table, and in particular they use sorry if I'm being a bit technical here, but I'm going to use the first frames to keep VCPU information, because the idea is maybe to use different frames for different information, so it's going to be extensible. Then I define a public structure that is going to be mapped by the tool in DOM0 to get this information. Currently, the allocation is on demand, in the sense that the tool that queries this counter from a domain has to request the resource, and in that moment, the resource is allocated. But it's not when the domain, when the guest is created, actually. And the allocation happens only when the domain is destroyed and all references are dropped. And also, we already have a very simple tool called SEN VCPU stat to show this new feature. And So this is the ongoing work. So we have, have us two versions of the feature itself, which are the first 3 lines, and the fourth line is the documentation about the acquire resource interface. And the idea to provide this documentation was, but maybe someone else want to use this interface for other purpose, so let's document it. Yeah. So all those patches are in process of review. So that's it. I'm done. I don't know if you have any question. Yeah.
What's the progress on this proof of concept tool in the xcp-rrdd plans that we have?
Sorry, say again.
So for xcp-rrdd, the proof of concept does not take that into account. So what are the next steps to integrate your work into that?
Yeah. So the question is how the work is going to continue in the area of xcp-rrdd. I'm not sure yet. I have to figure out how to integrate this change in the xcp-rrdd. I'm not sure yet. For the moment, what I have is only a simple tool in tool mix that show the functionality, but I didn't yet see the change there.
You can have a session if you want.
Sure, cool.
What about frequency of updating these statistics? I understand that xcp-rrdd tool query every 5 seconds, which is not that often. If this resource page is updated, much is updated, going to be worse performance? What are
It's possible. Yeah, I couldn't yet measure. And that is one of the things I was discussing with, I don't remember his name, but because we provide a solution, but I wanted to really compare it instead of benchmarking, to say, yes, this is a better solution. And because what we can say is, well, you're going to reduce the numbers of hypercalls for sure. And if you have more VCPUs, we're going to have more hypercalls too, right? And but then that use case, maybe it is not very often. So at the end, you don't gain too much by using this interface, right? So I'm not sure. In the case of acquire resource, you have only one hypercall to set up everything, and then you read it from there. You don't need a hypercall at all.
Then you make a hypervisor to update those tasks.
Yeah, this is, yeah. So you have the contention somewhere else. I mean, yeah. I couldn't measure yet. But if you have any example that I could try.
I'm wondering about somehow configurable update frequency. Like if your tool is querying every 5 seconds, maybe the hypervisor update every 5 seconds.
Yeah.
Maybe we could have a single hypercall that says, okay, update all the stuffs.
Yeah.
And maybe you call that every 5 seconds. It's not specific for each statistic, but then back to the original problem.
Yeah.
But we could make that option, right?
Yeah. Thank you. Yeah.
So I don't see any sense in saying the hypervisor should update only every 5 seconds. It's just the memory, and the hypervisor has to store information somewhere in memory, so it could just update the memory in place. It's not as if the hypervisor would reserve one processor register for the statistics. Does it do any aggregation? I mean, yeah, where in memory? Yeah, so it can be just done at the page is mapping to user and zero. So there's no need to have a buffer somewhere. It just adds latency basically. Yeah, it's a lot easier to just do the update. Yeah. But of course, the update needs to be atomically because otherwise the test could, the observer could read the counter just while the update is happening just by device. It would be an inconsistent value. But this is true even if the hypervisor will copy it to the page every several seconds or whatever. So. basically it doesn't matter. But I think just using the statistics page directly would be much more accurate.
Yeah, it's the same page that the hypervisor naturally store it, right?
Okay. That's all. Yeah. Okay. Thank you.